Good afternoon, boys and girls. Today we want to quickly revisit the topic on sketching cubic graphs. And from our previous lessons, I said in general, cubic functions are of the form f of x is equal to ax cubed plus bx squared plus cx plus ad, where a, b, c, and d are constants. Now, before we actually go through the steps that we take when we are sketching cubic functions, I need to introduce to you the remainder and the factor theorems. The remainder theorem states that if a polynomial f of x is divided by a linear polynomial ax plus b, then the remainder r is given by f of minus b over a. And the factor theorem states that if f of x is a polynomial and f of minus b over a is equal to 0, then ax plus b is a factor of f of x. And the converse to the factor theorem states that if ax plus b is a factor, then f of x, then f of minus b over a is equal to 0. Please understand that. Please note that sometimes our a is 0. Our a is 1. Then our f of minus b over a is exactly the same as f of minus b because a is 1. I'm going to look at a few examples to reinforce your understanding. Find the remainder when f of x, which is equal to 2x cubed minus 4x squared plus x is plus 2, is divided by ax plus 2. What it means here is that we are looking for f of minus 2 because our a is 1. So when we solve this, when we equate this to 0, when we solve it, we get a minus 2. That is why we find f of minus 2. When you substitute your 2 into the function, you get a minus 32. You are simply using your calculator. So the remainder is minus 32. Part B, when we have x minus 1, which means we are talking of f of 1 because we equated this to 0, x is equal to 1, so f of 1. So substituting 1 wherever there is x, we end up with 1. So this is the remainder when x minus 1 divides f of x, which is defined by 2x cubed minus 4x squared plus x plus a 2. Then we have 2x plus 1, which means when we solve, equating this to 0, when we solve, we shall get minus half. Again, we substitute minus half wherever there is x, and when we use our calculators, we get a quarter. Then part D, we have this equated to 0 and solve for x, we have 3 over 2. So f of 3 over 2 will be equal to, we substitute 3 over 2 wherever there is x, and we end up with 5 over 4. Second example, when f of x is defined by x cubed plus m of mx squared minus 5x plus 4 is divided by x plus 1, the remainder is 10. Find m. Well, all we are going to do is we have a factor. If we equate this to 0, our x is minus 1. So we substitute a minus 1 wherever there is x, and we shall have that. Wherever there is x, we substitute a minus 1, we simplify, and we solve for m, and our m is equal to 2. Very, very important for us to understand. Number 3, we are required to factorize. What are we factorizing? We are factorizing 2x cubed minus x squared minus 13x minus 6. Now listen to me carefully. I want you to understand how we identify the factors. We are going to select factors, and it's guided by the coefficient of x cubed and the constant. So we are looking at 2x cubed and minus 6. This 2 determines the factors. 2 has got a factor of 1 and 2, and 6 has a factor of 1 and 2 and 3 and 6. So if you are looking at those factors, we are saying the possible factors are x plus 1 or x minus 1, x plus 2 or x minus 2, x plus 3 or x minus 3. Now from here I'm just reading them as they are. X plus or minus 6, 2x plus or minus 1, 2x plus or minus 3. These are the possible factors. So we look at the first one. We substitute our f of 1, we get a minus 18. So it means x minus 1 is not a factor. We go for f of minus 1, we get a 4. Therefore x plus 1 is not a factor as well. Then we go to this one, f of 2, we get a minus 20. Therefore x minus 2 is not a factor. Then we go to x minus 2 plus 2. We have f of minus 2 is equal to 0. Yes, therefore x plus 2 is a factor. Which means the expression that is given is going to be a product of a binomial multiplied by a trinomial. Always a binomial multiplied by a trinomial. So our x minus 2, rather x plus 2, which is a factor, is going to multiply a x squared plus bx plus a c. Our task is to find a, b, c. And how do we do that? We use the synthetic division. And I want you to listen carefully. We agreed x plus 2 is a factor, which means x is equal to minus 2. So that is what we place here. X is minus 2. We make this division system and we write down the coefficients of our expression. 2, minus 1, minus 13, and minus 6. Right? Okay, I said we write down the factor. When we solve for x, it's minus 2, we place it there. And then we copy the coefficients of the cubic function, which is 2, minus 1, minus 13, minus a 6. Then the process is we drop down the 2. Then these 2 multiplied by that, we get a minus 4. Then we add these 2, we get a minus 5. Then this times that, we get a plus 10. We add these 2, we get a minus 3. This times this, we get a plus 6. So this plus this is 0. So it means the coefficients, that is a, b, and c, are actually what is underneath here, which is 2, minus 5, and minus 3. That is what we are going to have. Instead of a, we now have a 2. Instead of a b, we now have a minus 5. Instead of c, we now have a minus 3. Now we are able to factorize quadratic expressions. So it means we're looking for factors of minus 3, and which when multiplied by that, we end up with a minus 5. So you will notice that using the crisscross, we have 2x plus 1 and x minus 3. Then we are also required to solve x cubed plus 8x plus 17x plus 10 is equal to 0. Now we are solving. We said the factors are coming from the first term and the last term, the coefficient of x cubed and the constant. So there is x plus 1, x minus 1, x plus 2, x minus 2, x plus 5, x minus 5, then x plus or minus 10. I just put them together here because of space. So we are testing f of 1, we get 36. So it's not a factor. It means x minus 1 is not a factor. F of minus 1, we get 0. Therefore, x plus 1 is a factor. Using this synthetic division, we have, what is our x? It's a minus 1. So we have our minus 1 there. Then we copy the coefficients of the given expression. 1, 8, 17, 10. 1, 8, 17, 10. Then this 1 comes down. We just drop it. Minus 1 times 1, minus 1. Add these two, we get a 7. Minus 1 times 7, we get minus 7. Add this, we get a 10. This times that, we get minus 10. Add this, we get 0. So we should always end with a 0. If you don't get a 0 here, it means something is not correct. Therefore, that is equal to 0. We have x plus 1, which we discovered is a factor. Now we copy the coefficients. There is a 1x squared plus 7x plus 10. Now, are we able to factorize this? Yes, factors of 10, which when added, they give us a 7. That's 2 and 5. So we end up with that. Now we are solving. So x, either this is 0 or that is 0 or that is 0. So we end up with x is minus 1 or minus 2 or minus 5. Sure. Next example is saying solve for x. Given x cubed is equal to 5x plus a 2. All we need to do, we only solve when there is a 0 on one side. So we translate all these to the left hand side, which I have x cubed minus 5x minus 2 is equal to 0. Then when we are looking for these factors, it's actually happening in here. I was only teaching. It happens in here. You should be able to see what do we place in here to get a 0. So I realize it's a minus 2. So when you substitute there, you get a 0, which means therefore x plus 2 is a what? Is a factor. Using synthetic division, what is our x? Minus 2. We place it there, as I said already. We copy the coefficients in the expression. Remember, the x is having powers going down. So x squared is not there. It means there is a 0 on that position. So what is the coefficient? 1. There is no term in x squared, so it's 0. Then there's a term in x minus 5 and the constant minus 2. Then when you do the process, as I have said before, you get your 1 minus 2 minus 1, which then means that is actually the same as that, which is equal to 0. Now, this is equal to 0, or that whole thing is equal to 0. Because we can't factorize this, we use the quadratic formula, and we substitute our a, b, and c. We end up with x is equal to 1 plus root 2 or 1 minus root 2. Here is your classwork and homework.